Chapter 3, Section 4, Complex Numbers. In our last section, we were solving quadratics, and there were some where we would say no solution. If we were trying to square root a negative number, then we had to say, well, there's no solution there. Well, there actually is a solution, but it involves what's called a complex number. And complex numbers involve the imaginary unit I. Imaginary is kind of a bad name for it. It's not like it's fake, but it is something that had to be derived in order to actually solve things that have square root of negative numbers, because you can't really square root a negative number. So it just puts it in this other, mathematical frame, if you will. So instead of the real number system, we're in the imaginary number system. Okay, the imaginary unit, or the I, is the square root of negative 1, because you can't square root a negative number. This will allow us to always square root a negative number. We just pull an I off of there, turns the number into a square root of a positive, then we square root as normal. Okay. If r is a positive real number, then the square root of negative r equals I squared of r. For example, the square root of negative 3 equals I squared root of 3. By the first property, it follows that I squared root of r squared equals negative r, because I times I is going to be negative 1, and square root of 3 times square root of 3 is going to be a negative 3. Works just like that. So we're going to look at all the properties of complex numbers. This involves our exponent and radical properties that we're going to go back and forth through. So we just have to evaluate each expression. Okay. So basically the way I like to think about it is you're going to separate this into the square root of negative 1 times 25. That's the property that we're using with radicals, which then turns into square root of negative 1 times the square root of 25. Square root of negative 1 is an I. Square root of 25, 5 times 5 makes 5. So we got 5i. And I like to make my eyes with the little tail so I know that they're not ones. Now, you don't have to write this out every time, but it's what's kind of going on in my head as I process this out. As soon as I see the negative, I know an I comes out of there. Then I just process the 72, which I know is 8 times 9. That's 3 times 3. That's 2 times 4. That's 2 times 2. There's a 2's. There's a 3's. So a 2 and a 3 comes out. So I got 6i, because 2 times 3 is 6. There was an I already out there. And this little 2 stays in, just like that. Now I've already got a negative number on the outside, but it's going to become negative 5i, square roots of 9. 9 goes to 3 and 3. We got 2 3's, comes out, negative 15i. Just like that. Try 1 and 2 and 3 and 4 and see what you get. Give it a quick pause and then come back and see what I get. All right, number 1. Bring out the I, square roots of 4, that's 2. So we get 2i. Okay, let's see. And good. Square root of 12, well, that's I square root of 12. Break it into 4 times 3, 2 times 2. There's your pair. So 2i square root of 3. Just like that. Okay. So, negative I squared is 36. That's 6 and 6. So negative 6i. The 2 is already out there. I'm going to go 2i, get rid of the negative, and go 54, and then break that. That's 6 times 9. 9's 3 times 3. 6 is 2 and 3. I got a pair of 3's, and I got 2 and 3 left over, so 3 comes out. So 6i, square roots of the 6 stays with the 2 times 3 that are singles. So we got 6i square roots of 6. That's all you got to do. That negative, just pop it out like an I, and that's all it takes. Now, I to an exponent. Remember that I squared equals negative 1. Okay, I is the square root of negative 1. I squared equals negative 1 because a square root times itself, I should have an equal sign. A square root times itself is the number underneath. So I to the third Okay, as they say up here, equals I squared times I. I squared is a negative 1, so you get negative I. I to the fourth is I to the third times I. I to the third was negative I times an I, makes it negative I squared, makes it a positive 1, because it's already negative, and I squared is a negative 1. Negative, negative makes positive. I don't kind of think of them in that fashion, like separating one I off every time. I kind of think of them in squareds. An I squared is going to be a negative 1. 2I squareds, like I to the fourth, is a positive 1. I to the third, you're going to pull an I off, and then you got an I squared, which is negative 1. I to the first is just I. Okay, they go by a whole divides by 4 situation, and I don't do that. I look for different things whenever I try to evaluate these. I look for how many pairs do I have? How many pairs, right? How many squareds? How many I squareds are in there? An even number of I squareds, an even number of negative things is going to end up positive. An odd number of I squareds, odd number of negative things, ends up negative. So let's look at some examples. Evaluate I to the 27th. Here's how I work this, right? I to the 27th. 27 is not an even number, so I'm immediately going to pull an I off of there and then make it I to the 26th. Then I'm going to divide it by 2. Okay? I'm going to see how many I squareds are there. Right? So I divide this by 2, which is a 13. There is an odd number of I squareds. Well, every I squared is a negative 1. Every pair of negatives is going to be a positive. That means we'll have 6 pairs and 1 left over. So it's going to be right back to a negative 1. So this is going to be negative I. So if it's odd, pull an I off of there. Then take what's left and divide it by 2. If that's odd, it's negative. If it's positive, or if it's even, it's positive. If it starts off even, you don't have to pull an I off of there because it'll go into pairs. Divided by 2. How many pairs do you get? Odd number, negative 1. Even number, positive 1. So evaluate the power of I. Try 5, 6, 7, and 8. See what you get. And then I'll show you how I do it. You can also do it the book way, which is the divide it by 4 situation, and you can try that. I've never done it that way. I've always learned it this way. So, give it a go. All right, let's look at 5. 34 is already even. I don't have to pull an I off of there, so I know it's going to be a 1. Now it's just, is it positive or negative? Well, divide 34 by 2. That's 17. It's odd. Odd's negative. Okay. Let's see. I to the 47th. I'm going to have to pull an I off of there. Now it's 46. Divides by 2. It's 23. It's odd. It's going to be a negative I. I to the 65th is odd. Pull an I off of there. Now it's 64. Divided by 2. That's 32. That's even, so it's just a regular old, plain old positive I. This one's already even. Divided by 2. Let's see, that's 520. That's even, so it's just going to be 1. Not an I. Didn't have to pull anything off of there. And that's all it does. If it's an odd number, pull an I off. Then figure out, is it positive or negative? If it's not an odd number, you don't have to pull an I off. It's a 1. Figure out if it's a positive or a negative one. Complex numbers. Okay. We were just dealing with imaginary numbers. Complex number is a real number plus or minus an imaginary number. Okay, so an A plus BI, where A and B are real numbers. A is the real part, BI is the imaginary part. Technically, every number is this, because if you look at real numbers, they're A plus 0I. Imaginary numbers are A plus BI, where B is not a 0. Pure imaginary numbers don't have a real component to them that's 0 plus BI or just BI. Okay. So let's look at operations. You can add and subtract them. All you have to do is add and subtract the like terms. Real parts with real parts, imaginary parts with imaginary parts. It's very simple. They do a whole separate things out. I kind of just underline things that are like each other and combine those in the way that I'm supposed to. So let's check out an example. Add, subtract, write it in standard form. Standard form is real, then imaginary. Imaginary part's already last. When it's a plus, I don't have to distribute anything in. So 8 and 5 are like each other, and I and 4i are like each other. So 8 plus 5 is 13. Negative I plus 4i is 3i. Just add the like terms. This, I'm going to distribute the negative. So I'm going to change this to plus, and I'm going to distribute negative into here and negative into there and change that to plus. Okay, so now I don't have to worry about the minusing part. It's all built into the pieces. So 7 and negative 3 makes 4. Negative 6 plus 6 makes none. Okay, I got a negative here in front of the 2 and the 7i. So I'm going to distribute that in. It's going to make that a negative 2. And it's going to make it a negative 7. The negative 2 and the 13 are like each other. 13 and negative 2 makes 11. The negative 7i and the 5i are like each other now. And that's going to be minus 2i. That's all it takes. Just do the likes and the likes. Just watch out with the minus sign in between the parenthesis sets or in front of a parenthesis set. Just distribute that in and get rid of it. Turn it into a plus and not even worry about it. That way you know where the negatives are on everybody. Makes it way easier. Multiplying. Multiplying two complex numbers. Just distribute. Or FOIL. Or you can do the box method. I'll show you the box method on one of them. Okay. Just as you do when multiplying real numbers or algebraic expressions. I's exponents add up whenever you multiply an I times an I. The base is the same. But I is special. Remember, I squared equals negative 1. So if you ever hit a negative or an I squared, change it out with a negative 1. So let's see how that looks. Here I've just got something times a parentheses, so I'm just going to plain old distribute. 4i times negative 6. Positive times negative is negative. 4 times 6 is 24. I. 4i times I. It's 4i squared. That's a negative 1. So negative 24i minus 4. And I write it in standard form, plus negative. Negative 4 minus 24i. Just rearrange the pieces, and that's in standard form. Now with B, we've got binomial times binomial. That's back to FOIL. First, outer, inner, last. First times first. 9 times negative 4 is negative 36. Outer times outer. Let's see, 9 and 7 is 63i. Inner times inner. Negative 2i and negative 4. Negative negative makes positive. 2 and 4 makes 8i. And then negative 2 times I times 7i. Negative times positive makes negative. 2 times 7 is 14. I times I is I squared. Whoop, that's important. It's a negative 1. Okay. So that actually changes this. So negative 36 plus 63i plus 8i plus 14 because of that negative times negative. Now we combine the like terms. This and that are like each other. This and that are like each other. Negative 36 and 14. Let's see, we're going to go. It stays negative. Going down 10 to 26. Down 4 more to 22. 63 and 8. 71i. Just like that. If you don't like FOIL, you can also do the box method. Do the box method in blue. Show you what you get. Okay. Box method in blue. What you should get. So you just take one of each, just like a Punnett square. A 9 and negative 2i. Negative 4 and 7i. And this what's on either side of the box is what multiplies. So negative 4 and 9 is excuse me. Negative 36, 8i, 63i, and negative 14i squared. That's important. Changes the sign. Makes it positive. Then whenever you're doing this, your diagonals are your like terms. Negative 36 and 14, negative 22, 63 and 8, 71i. Same answer. Box method, FOIL, whatever makes you happy. All right, here we got some try. Okay. All you need to do is add, subtract, or multiply these. So, and write it in standard form. Real part, then imaginary part. Try 9, 10, 11, 12, 13, 14. And then come back and See what I get. All right, let's do 9. 9 minus I plus negative 6 plus 7I. 9 and negative 6 are like each other. Negative I and 7I are like each other. So we're going to get, let's see, 9 and negative 6 makes 3 plus 6I. Let's try 10. 3 plus 7I minus 8 is negative 2I. I'm going to go ahead and get rid of that and distribute it into both. So change, change, change. 3 and negative 8 makes negative 5. 7I and 2I makes 9I. 11. 11's got some parts to it. Negative 4 minus 1 plus I minus 5 plus 9I. Get rid of your negatives. Move them in. So plus, change, change. Plus, change, change. Now let's look for our like terms. 4, negative 1, and negative 5. Negative 4, negative 1 makes negative 5, and negative 5 makes negative 10. We got I and I. Negative I and negative 9I, negative 10I. Just like that for 9, 10, 11. Now let's look at the multiply. Erase these, get some space here. Start with red. Okay, 12. All we got to do is multiply them together. Negative times negative makes negative. Sorry, negative times positive makes negative. 3 times 10 is 30. I times I is I squared. That's important. It's a negative 1. Negative times negative makes positive. Be careful with the I squareds. I times 8 minus I. Distribute it in. 8I minus I squared. That's important. It's a negative 1. Negative, negative makes positive. So we got 1 plus 8I. Just put it in standard form. 14. 3 plus I times 5 minus I. You can FOIL or you can box. This time I'm going to do the box just to show you. 3I. 5 minus I. 5 times 3, 15. 5 times I, 5I. 3 times negative I, negative 3I. And negative I times I is negative I squared. That's important. It's a negative 1. Okay, so negative negative makes positive, so it's positive 1. So 15 and 1 makes 16. And negative 3 and 5 makes 2I. Just like that. We can practice all of those rules. And then we'll keep going on with the harder stuff with I, and then we'll actually start using it to solve. Once we get to the solving part with I, it's a lot easier. All we're doing is pulling it out of the square root of a negative, but we do want to know how I works in functions. These are definitely testable things when you get to SAT, ACT, that kind of stuff. Two complex numbers of the form a plus bi and a minus bi, where b is not equal to 0. Okay, we need the whole complex, not just an pure imaginary. They're called complex conjugates. The product of a complex conjugate is always a real number. For example, 3 plus 2i times 3 minus 2i equals 9 minus 6i plus 6i plus 4. The negative 6i and the positive 6i in the middle, the O and the I of FOIL, basically cancel each other to 0. The I squared turns the negative 2 into a positive, the negative 4 into a positive 4. So 9 plus 4 is 13. We can do this to help keep the denominator rational. Remember, if you have an I in the bottom, you technically have the square root of negative 1, and square roots in the bottom are a no-no. You'd have to multiply by square root of negative 1 over square root of negative 1, or I times I over I. But when you have a complex number, you want to multiply by its conjugate. So just change the sign in the middle. You don't even have to rearrange the letters or numbers or nothing. You just have to multiply it by the one in the middle. This also works with radicals. If you have 1 plus the square root of 2 in the bottom, you just multiply it by 1 minus the square root of 2, top and bottom. And it will get rid of your radical. That's how you rationalize complex or a radical denominator. So all we're going to do is multiply it by what is in the bottom but we're going to do the opposite side. And we're going to do it to top and bottom. Okay. You'll start to learn this, but the O and the I always cancel each other out. That's why we do this. It gets rid of I in the middle. So all we have to worry about is F and L, the first and the last. So 1 times 1 is 1, and negative 2i times negative 2i makes negative 4i squared. That's a negative 1, so bloom, bloom. 1 plus 4 is 5. Now the top is the hard part. That's where we're going to need the box. Because we got 4 plus 3i, and we got 1 plus 2i. 1 times 4 is 4, 3i, 8i, 6i squared. That's a thing, so it makes it negative 1. So that's a negative 6. 4 and negative 6 is negative 2. 8 and 3 is 11i. Make negative 2 plus 11i on top right there. Oh. Okay. You could separate these. This is the same thing as negative 2 over 5 plus 11i over 5. I'm fine with this answer. Okay. Just make sure your complex part is in standard form, so the reals first and the imaginaries second. Let's look at B. What we should do on B. Well, we're just going to multiply it by 2 minus 3i, top and bottom. Okay. 2 times 2 makes 4. 3 times negative 3i is negative 9i squared. That's important. It's a negative 1 plus positive, so we get 13 on the bottom. Now we just have to box it. Or FOIL, whatever makes you happy. 1 minus 4i, 2 minus 3i, 2, negative 8i, negative 3i, 12i squared. That's a negative 1, so it makes it negative 12. So that's negative 10 and negative 11i. So negative 10 minus 11i should be just like that, all over 13. So we can separate them into 2 pieces or leave it in one. I'm going to leave it in 1 piece kind of person, but make sure you know that you can find that separation if you need to. And lastly, let's look at the last one. It's actually not a complex number. It's just an imaginary in the bottom. So all you have to do when it's this is just multiply by I, top and bottom. Makes it much easier. We get 4i squared. That's important because that's a negative 1, so we get a negative 4 on the bottom. I times 2, 2i. I times 5i, 5i squared. That's important. That's a negative 1. So that makes it negative 5 plus 2i. Now here the separation kind of important because you may see this answer in this way, so I'll show it to you. All right, if we get negative 5 over negative 4 plus 2i over negative 4, you could reduce, actually it wouldn't be a negative. The negative simplifies away and you could say minus, and 2 over 4 makes 1/2. So you could just have I over 2 and be another way you might see that, or plus negative I over 2, something like that. But I'd probably stop right about there just so I know what it is. That's how it would go. Try 15, 16, 17 on your own. Come back after a pause and then watch me do them, and I'll show you what the answer should be. Okay, here we go. 15's got a complex on the bottom, so multiply by the opposite sign in the middle, top and bottom. 4 times 4 is 16. I times negative I squared. That's important. It's a negative 1. Negative makes positive. 17. Let's do the box. Oh, heck. Yeah, I'll FOIL on the next one. Oh, I don't have to FOIL on the next one. Cool. So 2 minus 3i. 4 minus I, 8, negative 12i, 2i, 12i squared. That's important. It's a negative 1, plus plus. So 8 and 12 makes 20. Negative 12 and negative 2 makes negative 14i. So 20 minus 14i I over 17, which is not very helpful or reducible, so leave her right there. Erase my box here. Complex number on the bottom, so we just multiply by the complex conjugate, which is 4 minus 6i, top and bottom. 4 times 4 is 16, and that's negative 36i squared. That's important. It's a negative 1 plus positive. Let's see. 46, so 52. 7 times 4 is 28. And 7 times negative 6i is negative 42i. Now, here's something special. 28 and 42 and 52 all can divide by at least 2. So we should simplify it down. So if I divide 28 by 2, because the 52 goes into both of them and 2 goes into all of that, so you should reduce it if it goes into all of it. So that would make it 14 minus 21i over 26. And let's see. Does anything go into all of that? Doesn't look like it. 7 goes into the tops, but not into the bottom, so then we should get down to just that guy right there. But always check them. And if you need to, pull up your calc. Oh, it's not really the calc I wanted, but you can do 14 divided by 26. And then, let's see, switch it. 7/13, and I can do 21 divided by 26, and it just does 26, so that's as small as it can get. So that's what we want to do there. Okay, and then 17. Let's try 17. Making some room here, getting rid of that one. Not a complex, so all I need to do is get rid of the I, the radical part of that. So on the bottom, I got 3i squared. That's important, it's negative 1, so negative 3 goes on the bottom. 6i. Oh, I wanted that up here, not down there. Excuse me. Plus 5i squared. That's important, it's negative 1. Makes it negative 5 plus 6. All right, now you could separate them and reduce the 6 and the negative 3, or I would probably just keep them all as one thing. Complex solutions and zeros, solving quadratic equations. So now we don't have no solution anymore. Now we have I to help us out. So let's look at A. X squared plus 4 equals 0. Well, I don't have a linear term, so I'm going to do it algebraically. Subtract 4 from both sides. X squared equals negative 4. Normally, if I tried to do the square root, I'd be like, oh, I got to stop. Can't square root a negative. But now that we have the complex idea, we know we can. This is going to be x equals plus or minus I square root of 4. Square root of 4, 2. So x equals plus or minus 2i. That's what we're looking for there. Let's check out B in blue. 2x squared minus 11 equals negative 47. Got to set it equal to 0, so let's add 47 to both sides. Actually, I wanted to get x by itself. Let's do that the other way. Since I don't have a linear term, let's just get x by itself. Let's add 11 to both sides. 2x squared equals negative 36. Divided by 2, x squared equals negative 18. Square root both sides. Don't have to worry about the negative anymore. Plus or minus I square roots of 18. 2 times 9, 3 times 3. There's my pair, there's my single. 2 stays in, so x equals plus or minus 3i square roots of 2. Stays right inside. Finding zeros of a quadratic function. This is what we're talking about. Normally, what we're looking for whenever a quad crosses the axis is where does it touch the x-axis? This way, or if it's here, that way. But, or maybe it just touches once, right there. But what if it doesn't touch at all? That's where the imaginary comes in. That's how you can tell graphically it's going to have an I in the answer. Okay, it has to have it. So if we're doing function stuff, remember this is basically y equals, and in order to solve, you do 0 for y. Now we just get the x by itself. There's no linear term. We can do it algebraically. Subtract 20. Negative 20 equals 4x squared. Divide by 4. Negative 5 equals, right, x squared. Square root both sides. I square roots of 5 plus or minus equals x. 5 doesn't have a square root, so we're stuck right there. That's as simple as it gets. For that square root of the negative, just pop an I out of there, and then it's just square root as normal. All right, so they want you to solve all of these equations. Basically, it's the same thing, because that f of x part is just a y, and all we're going to do with y is turn it into a 0, and then we're going to get x by itself. So try 18 through 26 on your own, give it a pause, and then come back and see me do them. All right, let's do the top three, 18, 19, 20. 18's x squared equals negative 13, square root both sides. X equals plus or minus square root of negative, pull out an I. 13 doesn't have a square root. Nothing goes into that. 13 and 1, so just square root of 13. Done. 19, x squared equals negative 38. Square root both sides. X equals plus or minus I square root of 38. Let's break it. 2 times 19. And those are prime, so didn't even need that. It's going to be right back there. 20. X squared plus 11 equals 3. Normally we set equal to 0, but since we only have quadratic, no linear, we can do it algebraically. Let's subtract 11. X squared equals negative 8. Square root both sides. X equals plus or minus I square root of 8. Break the 8. 2 and 4. 2 and 2. There's your pair. This one stays. Those are broken. X equals plus or minus 2I square root of 2. Don't forget your I. Just like that. Okay. 21, 22, 23. Start with the red. 21. X squared minus 8 equals negative 36. Add 8. X squared equals negative, let's see, 6 down. We got 2 left, negative 28. Square root. X equals plus or minus I square root of 28. 4 and 7. 2 and 2. So x equals plus or minus 2I square root of 7. Stay just like that. Let's try 22. 3x squared minus 7 equals negative 31. Move that 7. 3x squared equals negative 24. Yep, 7 down. Yep, that would work. Divide by 3. X squared equals negative 8. Square root. X equals plus or minus I square root of 8. Break it. 2 and 4. 2 and 2. There's my pair. That one stays. So x equals plus or minus 2I square root of 2. You'll start to memorize the square root of 8. You'll do it enough. 23. 5x squared plus 33 equals 3. Subtract 33. 5x squared equals negative 30. Divide by 5. X squared equals negative 6. Square root. X equals plus or minus I square root of 6. It doesn't have a square root, so I can stop right there. 3 left. The last 3 are function notation. Function notation is no different than regular, XY notation. F of x means y. That's what's there. Okay. So for 24, 0 equals x squared plus 7 minus the 7. Negative 7 equals x squared, square root. I know what you're thinking. The x squared is on the wrong side. Doesn't really matter. It's equal. Left to right, they mean the same thing. So x equals plus or minus I square root of 7. 7's prime. Doesn't have a square root. 25. 0 equals negative x squared minus 4. Add 4. 4 equals negative x squared. Divide by negative 1. Get rid of it first. Negative 4 equals x squared. Square root. Pull out the I. And we get plus or minus I squared root of 4. And square root of 4 is 2. So plus or minus 2i. And 26. 0 equals 9x squared plus 1 minus 1. Negative 1 equals 9x squared. Divide by 9. Oh my god, it doesn't divide by 9. Negative 1/9 equals x squared. Whatever will we do? It's a fraction. So what? Square root both sides. So you got plus or minus I square root of 1 over 9 equals x. The thing with the square root of 1/9. It's the square root of 1 over the square root of 9. Square root of 1 is 1, square root of 9 is 3. So, plus or minus 1/3 I. That's it. Square root of 9, square root of 1. Square root of 1 is 1, square root of 9 is 3. 1 comes out, 3 comes out, boom, boom. 1/3. That's all there is to the i's. Don't forget the part about no I in the denominator. If it's just a pure imaginary number, just a number I, just multiply top and bottom by I each. Okay, remember your I squared turns into a negative 1. If it's a real plus an imaginary, a complex number, use a complex conjugate. Do the opposite sign, same number front, same number back. That'll get rid of it.